Hello and welcome. In this video we will derive a formula for the quotient rule of derivatives. The quotient rule states if the functions f and g are differentiable at x and g of x is not equal to 0, then the function f divided by the function g is also differentiable at x, and the derivative of the function f of x divided by g of x is equal to the function g of x times the derivative of the function f of x minus f of x times the derivative of the function g of x. All this divided by the denominator, which is g of x squared. Now let us prove this rule. Derivative of the function f of x divided by the function g of x is equal to limit as h approaches 0 f of x plus h divided by g of x plus h minus f of x divided by g of x, all this divided by h, and that gives us limit as h approaches 0. Now if you apply the rules for subtracting fractions, you will have f of x plus h times g of x minus g of x plus h times f of x, all this divided by h times g of x plus h times g of x in the denominator. Now adding and subtracting, f of x times g of x in the numerator. That gives us derivative of the function f of x divided by g of x equals to limit as h approaches 0 f of x plus h times g of x minus f of x times g of x minus g of x plus h times f of x plus f of x times g of x. We are adding and subtracting f of x times g of x simultaneously in the numerator. This is where we subtracted, and this is where we are adding them. all this divided by h times g of x plus h times g of x. Now we can factor out some of the terms in the numerator and apply the rule of divisions. That gives us limit as h approaches 0. Now if we factor out the g of x in the numerator, you would have f of x plus h minus f of x divided by h minus, and you can factor out the f of x term. That leaves us with g of x plus h minus g of x, because the negative sign comes out. And there is a bracket. Now this has left us with the denominator g of x plus h times g of x. Because the h is distributed among the terms in the numerator, so we don't have h in the denominator now. So now applying limits as h approaches 0 to each term in the numerator and also in the denominator, that gives us the derivative of f of x divided by g of x equals, we are applying the limits to each term in the numerator and the denominator. That gives us limit as h approaches 0 and limit as h approaches 0 f of x plus h minus f of x divided by h minus limit as h approaches 0 f of x times limit as h approaches 0 g of x plus h minus g of x divided by h, and all this divided by limit, because we have to apply the limits to the denominator as well, g of x plus h times limit as h approaches 0 g of x. Now as we can see, because there is no h term in each of these limits, limit as h approaches 0 g of x is equal to g of x, and limit as h approaches 0 f of x is also f of x. And since g of x is differentiable at x, limit as h approaches 0 g of x plus h approaches a value of g of x. So replacing limit as h approaches 0 g of x, and limit f of x as h approaches 0 with f of x, and limit as h approaches 0 g of x plus h with g of x, we get derivative of f of x divided by g of x is equal to, we are replacing limit as h approaches 0 g of x with g of x. That gives you g of x, and all this limit as h approaches 0 f of x plus h minus f of x divided by h can be written as derivative of the function f of x minus, and limit as h approaches 0 f of x is f of x, and replacing limit as h approaches 0 g of x plus h minus g of x divided by h with the derivative notation, and in the denominator you have as g of x plus h, a limit of g of x plus h as h approaches 0 is g of x. So that gives us g of x times, times g of x times g of x, which is equal to g of x times derivative of f of x minus f of x times the derivative of g of x. All this divided by g of x times g of x is g of x squared. Now we can see that the derivative of the functions f of x divided by g of x is equal to, in general terms, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. All this divided by the derivative, all this divided by the square of the denominator. So in general terms we can write this as the derivative of a function f divided by g is equal to g times, which is the denominator, times the derivative of the numerator minus numerator times the derivative of the denominator, all this divided by the square of the denominator. This is the quotient rule of the derivative of two functions.